everything is all based on this TCP/IP. But if you go back to long history, maybe 30, 40 years ago, different vendors, different manufacturers, vendors, and so on, they use their own protocols, own proprietary protocols, right? But those days, of course, we didn't have internet like as of today. So that is why they use their own protocols, or in other words, set of rules. Protocol means a set of rules, right? So nowadays we talk about TCP/IP because internet is all based on TCP/IP. Now, what is the purpose of this? What does it do? What does TCP do and what does IP do? So we said, it's a standard, it's a protocol, right? So if you want to talk to, say, if it's a kind of language, right? So if we have to have some kind of common language, we have to have some common agreements. So in TCP/IP, if you want to send some packets from one host to another host, or one place to another place, these hosts, they have to agree upon certain rules, certain standards, right? It's just like, when we speak to each other. If I speak to you in some certain language, you can understand that, because now if I speak in English, you understand that because we both follow the same rules in English language, right? In the same way, if we have one host speaking TCP/IP, and if we have another host out there speaking TCP/IP, if they follow the same rules, they can understand each other, they can communicate each other, they can send packets from one place to another place. So we have two things here, as I said earlier. So IP is the internet protocol. The main purpose of IP is to make sure there is an identification, because every device that connects to the internet needs an identification. That's what the IP gives us. What about TCP? What is the purpose of that? So we have an identification. So if I'm going to talk from one, say, one host is going to talk to another host. So we need to have identifications for those hosts. And the next thing is, if we are going to send packets from one place to the other place, we need to have some reliable delivery of those packets. So that is what TCP enables, right? TCP stands for Transmission Control Protocol, things like error corrections. Think about you're sending letters in the real life. So if you want to send a letter from yourself to one of your friends in another country, right? So if you have to make sure that this letter gets delivered properly, you have to actually add some certain rules for that, right? So that's what actually TCP does. It's called Transmission Control Protocol. So anyway, the bottom line is that if you're talking about internet today, so this is the protocol that is based on TCP/IP, right? One important thing. So that has got different layers. So what are the layers in TCP/IP? We have 4 layers. So we have application, transport, network, and physical. So what's the purpose of all these? So if, say, in this case, in the left side, you have one host, and in the right side, you have another host. So if you take the host in the left side, if that particular host has to send some data or packets to the destination, obviously, first of all, you have to have an application first, right? Something like a browser or mail client, that's an application. And then it has to be properly organized so that it can be, all this data can be transmitted, transported. So that is what is happening in the transport layer, packaging. Then we have network layer. In the network layer, what do we do? In the network layer, we give directions, right? Things like routing, the directions. So that's what's happening in the network layer. Even identifications. We talked about IP, the internet protocol. So that's all coming in that layer. And then the last layer, the physical layer. So what's the purpose of that? So it's no point we have everything, but if we don't have physical networks, the physical mediums, we have to have the physical mediums. So say, for example, it could be a Wi-Fi network, it could be a fiber network, it could be a satellite link. These are all the physical networks. We have to have those. So we have to make sure that we fulfill all those different rules and criteria for us to send data through all those layers and then send it to our destination, right? So these are quite fundamentals in terms of standards that we use. Next thing, internet identifiers. What are internet identifiers? Anyone? Can you give some examples? Internet identifiers. Yeah, yes, domain names. Good. Anything else? So what does, when you say internet identifier, it is some identifier, right? So it should identify something. If you connect something to the internet, that should identify something. So a domain name is an identification, and then or IP address, that's an identification, right? So these are all internet, that's what we call internet identifiers. So it is very important for us to actually manage these internet identifiers quite responsibly. So I was asking before, how many of you manage networks? There have a few people here, right? Raise hands. You manage networks. So if you manage networks, you have to have, if you are connecting some devices to the internet, it could be a mobile phone, it could be a laptop, it could be a printer, anything, right? If you connect these to the internet, we need to have these IP addresses. We know that. But then important thing is we have to manage these internet identifiers quite responsibly. Where do you get these IP addresses? Do you know where these IP addresses come from? Anyone who has your IP address, who has IP addresses in your network, where did you get it from? Ayana? Did you directly get it from Ayana? No. Where did you get it? ISP, yes. So in a typical situation, right? Say when we want to have an internet connection in our home, right? So you go and talk to your ISP, right? So your ISP gives that connectivity. So ISP gives that IP address. So, and where does the ISP get that IP address? ISP gets it from? So these are all part of this whole internet ecosystem, right? Because when we talk about internet identifiers, try to understand, where these resources come from. So if where ISPs get from what we call regional internet registries, or RIRs, regional internet registries. There are 5 regional internet registries in the world. So for Asia Pacific, we have an organization called APNIC, right? So the organizations in Sri Lanka, say for example, we have Asela from SLT, or any organization here in Sri Lanka. If you need some IP address, especially the large amount of IP addresses, if you need a small amount of IP addresses, then you may go to an ISP and get an IP address block. But if you need large amount of IP addresses, then you may go to the regional internet registry. But then there is also actually, someone said IANA here, right? So what is IANA? So IANA stands for Internet Assigned Numbers Authority, right? Until very recent, see, you talk about IANA, but then in the recent time, there was something, maybe you may have heard about something called IANA transition, because this body, IANA, of course, it's, I talked to you about ICANN before, so you can even say that IANA is the operational arm of ICANN as well. It's a department, right? So IANA, now the IANA function has been transitioned to another entity called PTI now. So the current entity is called PTI. So PTI stands for Public Technical Identifiers. So PTI, or formerly IANA, that is the body that keep the central pool of IP addresses, right? Central pool of IP addresses, and then they would distribute to the regional internet registries like APNIC, I said, right? Or in Europe, we have RIPE-NCC, in the North American region, we have American Registry for Internet Numbers, or ARIN. So these RIRs, they are the ones who distribute these IP addresses in their particular region, right? So that's how these IP addresses actually get into your device, even if your mobile phone or even if your laptop, right? So you have that IP address. Obviously, in IP addresses, we have different type of IP addresses. We have private IPs. We also have public IPs. So I'm talking about public IPs here, right? Private IPs, of course, there are certain ranges defined as private IPs. So if you are a network manager, if you are a network sysadmin, you can use these private IPs based on your requirement within your network, right? But private IP should not be going into the outside world. It should be only used within your local environment, local network, right? Okay. Now, have you heard that in these IP addresses there are two versions? Yes. So we have IP version 4, and then we have IP version 6. Why do we jump from V4 to V6? What happened to V5 then? Anyone? There was V5, but it was an experimental version, right? So we have IPv4. In fact, IPv4 has been there for a very long time, since mid of 1970s, right? IPv4 is a 32-bit number. IPv4 address is a 32-bit number, right? And then in the 1990s, IPv6 was developed or designed. Why it was designed? Because IPv4 has quite limited amount of IP address space. How many IP addresses do you think that IPv4 can have? Yeah, very good. 4.2 billion. Why is that? Because when you talk about 32 bits, right? So bit means base of 2, right? So you take 2 to the power of that. So 2 to the power of 32, because it has got 32 bits. So when you have 2 to the power of 32, that gives you around 4.2 billion addresses. But back in 1970s or 1980s, 4.2 billion was a big number, because there were not many computers, that many computers, of course, in the world, because those days it was mostly on, when we say computers, 1970s, 80s, we talked about mainframes or mid-range computers and so on, right? Not just even PCs. PCs came in the 80s, not laptops and so on. But nowadays you're talking about mobile phones, devices, little devices and so on, right? So if you're talking about 4.2 billion now, it's nothing, right? It is not enough at all. So people realized that back in 1990s. But one problem was, in early days, say especially in 1980s and 1990s, these IP addresses were distributed based on a classful structure. What do you mean by a classful structure? So they have defined few classes. They define class A's, class B's, and class C's. I mean, probably during that time it was a better mechanism because of the requirements they had. Class A was meant to be for large networks, and class B was meant to be for medium-sized, intermediate-sized networks, and class C was meant to be for small networks. So if you take, say, this 32-bit address, you can divide that into two parts. I won't go into too much detail here, in case if you're not into the network engineering side, this might get confused. But based on the 32 bits address space, they have created two divisions. One is what we call host side of the address, and the other is called the network side of the address. So based on that, you can create large networks, intermediate side networks, or small networks. So those days, if any organization say, if you need like 100 IP addresses, when you request for IP address block, you may have got maybe a class C, right? So, but the problem is, if you say class C, that has got 8 bits in your host side. So which means 2 to the power of 8, that is like 256. You only need 100 IP addresses, but you get 256. So you are wasting like 156 IPs, right? But if you go further, say if you need like 1000 IPs, if you need 1000 IPs, class C is not enough. So if you are given a class B can have 16 bits into your host side. So you could pretty much have 2 to the power of 16. So that is if you calculate 2 to the power of 16, that gets you like 65,536, right? So, but you need only 1000. You get 65,000. So you are wasting a lot of IP addresses. And if you go even further, say you need like 100,000 IPs, if you have a global network, if you need like 100,000 IPs, class B may not be enough. So if you get a class A means 2 to the power of 24. So 2 to the power of 24, if you calculate, that gets you something like, what? Maybe about 16 million something. You need only 0.1 million, 100,000, but you get 16 million. So you're almost wasting more than 16 million IPs in that whole block, right? So this was a problem. So that is why actually by the 1990s or so, people saw that out of that IPv4 address space, pretty much half of that is gone because of this classful structure, right? I'm just telling this because I see sometimes when we speak to some network engineers even now, they still speak in classes, right? They say, I need a class C for my network. My customer is asking for a class C. So they still speak in class Cs. The class Cs are no longer, right? We don't talk about that now. Classes were deprecated back in 1995. So if you're talking about classes now, you're talking about something existed about 20 years ago, right? So don't talk about these classes anymore. Even if you're someone who is managing a network, don't even allocate or give IP addresses based on classes. Don't do that. That's because there's nothing like that. So now what we have is classless, right? So which means we don't have those fixed bit boundaries, 8, 16, 24. We don't have that. What we have is, changeable bit boundaries. If you need a certain amount of IP addresses, we can pick a certain size of network prefix where you can get an optimal amount of IP addresses for that requirement, right? So that is what we call classless. So just want to actually quickly highlight about that because in case if anyone's still using class full addresses, I just want to make sure that it should not happen in the future, right? Okay, quickly going into IPv6. So we said IPv4 by 1990 or so, IPv4 was almost running out, right? So we had to find some solution for this because if we continued at the same rate, by year 2000, these IPv4 addresses would have been exhausted, right? So that is why, first of all, one thing, you need internet policies. So that, because these are all resources, these internet identifiers, they're all resources, just like water, just like trees, they're all resources. So you have to conserve these resources. So that is why policies are needed. So those days, especially in 1990s onwards, regional internet registries and so on, they started working with the community in developing these policies. How should we use these IP addresses or these internet resources responsibly? You don't waste these, right? So these are things that those days, one of the priorities actually in terms of using these resources in a responsible way. And also, that is one thing, the policy side, development of policies and so on, that started happening. And then the other thing is developing a new protocol, that is IPv6. So IPv5, I said before, that was experimental protocol, but then IPv6 became a standard. In fact, it was earlier than that. There was something called next generation, right? So that became IPv6. So IPv6 has got 128 bits. So just imagine now, if you compare with IPv4 and IPv6, IPv6 is really, really big. You're talking about, if you count the number of IPs, I mean, you can't practically count it because that gives us 2 to the power of 128. even if you put that into your calculator, you won't get the number, right? 2 to the power of 128, you cannot calculate even in a calculator. So it's a huge amount of addresses. You can even think of a density. Say, for example, if you consider the whole globe, whole Earth, if you take every square millimeter, right, every square millimeter of the whole globe, you can fit in more than 1 million IPv6 addresses in a square millimeter, right? So that kind of density we are talking about. So it's really big, it's huge. But then IPv6 also has got a lot of challenges. Now that address, what you see in the bottom, that's an IPv6 address. Obviously, you know, if you have to deal with these addresses, it's not going to be very easy, like IPv4 addresses and so on, right? Even dealing with IPv4 also not very easy, right? It's not easy to remember and so on. But when it comes to IPv6, it can be even more challenging, right? So, and then one of the other big challenges is the routing side of it, because routing is another important aspect of internet communication, because we have to have a proper routing system for us to get our packets routed from one place to another place. In a real life example, if I tell you earlier, I said that if you want to send a letter from one place to another place, you have a postal system, right? You have a post office, postal system who can take your letters from one house to another house. In the same way, in the internet, right? If you want to take your packets from one host to another host, we have to have a routing system, just like the postal system. So in the postal system, you have post offices. In the same way, in the routing system, we have things called routers. So routers will do that sorting function. That's what happened in the post office, right? Post office people do letter sorting. They will put letters going into one country, into one place, and then sending that to another country, and so on. So there is some sorting happening. In the same way, what does a router do? Router would sort these packets and then forward it to another router, right? So that's what the router is. So routers are very important, and the routing system is also very critical in getting our packets from one place to another place. So, and having a good routing system, managing a good routing system is very important. Now, why I'm saying this, say, for example, think about, again, I'll try to give a real life example. Say you go to a new house, right? If you go to a new house, you will get a new address, because new house will have a new address, right? And if you want your friends and family to come to your new house, what do you have to do? You have to give your address to your family and friends. Then only they can visit your house, right? So in the same way, now, if you got a new IP block, coming back to, the IP addresses now, right? Say you want to start your own company tomorrow, right? If you want to start your own company, and you want to have some network there, you want to have your devices, networks, and all that within your company, right? So you have to get an IP address block for that. Now, if you have got an IP address block, that means you have got now new set of addresses. So if you want traffic to come to that network, or the internet traffic to get to that network, what do you have to do then? You have to, just like before, if you go to a new house, if you want your friends to come to that new house, you have to tell your address to your friends and family. In the same way, if you got IP address block, and if you want the traffic to come into your network, you have to announce or tell this IP address to the whole world, right? So then only traffic can come to your network. So this is what we call the routing announcements, right? So when you get an IP address block into your network, you have to make some routing announcements so that others can send traffic into that network. So that is why the routing system is very important, and the route announcements, or what we call route advertisements, are very important as well. Okay, so so I'll stop the routing part a little bit there. I've got some statistics here based on this Internet World Stats. So this is actually Internet users in the world, right? So if you see, Asia has got almost like I mean, these are in millions. So Asia has got almost like close to like 2,000 millions. So in other way, 2 billion, right? So 2 billion users, internet users are in Asia. Whereas you go all the way down, in the United States, you have around 320 million, and Oceania, Australia, around 30 million or so, right? So these are the internet users. Now, if you also actually, in the same scale, if you have a look, the internet penetration. So what do you mean by internet penetration? That means out of, how many of us actually, say if you take as a whole country, how, what sort of percentage are we talking about that the users who use internet? But if you go to North America, the penetration is almost like 90%. Even though in the previous slide you have like in North America 320 million users, but the penetration is almost like 90%. Yeah, so if say let's take Asia here, right? So in Asia we have around almost close to 2 billion users, but this, if you see the penetration is very small, like 40% or 40 something percent. So that means we still have to fill 50% more, right? Only 50% of Asian population has got internet access, right? Yes, fairly large. Yes, actually.
Area-wise also the penetration and connectivity, if you take it, also not that extended like in the United States.
So then we could say that maybe China accounts for a disproportionate amount of internet users. It doesn't seemingly make sense that you have 44% penetration, yet you have such a huge number of users.
Yeah.
If you're using, there's penetration.
Yeah. So what does it tell you? What does it tell you then?
That's what I'm seeking to understand. What's the difference between users and penetration, I guess?
Yeah. So that is just the count. That's the count. Count of.
Can there be usage without penetration?
If the Colombo is only connected to the internet, let's say we have 50% of the population here, number of users would be who are connected is actually in Colombo area. But let's say rest of Sri Lanka is not connected to the internet. Rest of the people may not connect, but we have large population here, like 50% of the people will be with the numbers. But when you take the area wise, the extension is very small. It's like 1/10.
Yeah.
Like.
Do you get the point that we are trying to?
So there's a geographic question
it's
here.
Like location. If you now what I'm trying to say is like this. Just to give a simple example, take the United States for instance. Washington DC is connected. Let's assume, all right. Washington DC is connected, but the population in Washington DC, assuming, right, like half of the population in your country would be in Washington DC. Then now it's about 250 million. Let's say we just assume 125 is in the Washington DC. But the rest of the America is not connected. But the users wise, you have 125 million connected anyway.
Yeah.
That means they count the number of people who go to the internet, but the area wise, it's not penetrated.
Right. So the difference between penetration and user, or one of the dynamics or issues, is geography.
And the population also dispersed through. If you take China, a lot of people are concentrated in cities like Shanghai. Mm-hmm. So there will be high numbers. Mm-hmm. So that the number wise, high numbers, but then China, the extent of the land may not be connected that far, and the people of those in those sparsely connected area, they are not also connected. So half of the people in Asia are not connected right now.
Yeah. So that's the bottom line. Actually, if you see here, only 44% of Asian population has internet access, but yet we have 2 billion users.
Because we have large concentrations. population concern in different cities like Shanghai, Beijing, those areas.
So we still have to grow more than 2 billion users
At
in
the
Asia.
moment, I think you should be knowing that the China is the largest right
Largest,
now.
yes.
Largest. Because we know that with the IDNs, now I think IDNs are becoming bigger and bigger, right?
Yes,
I mean, the
yes.
number.
I'm going to talk IDNs as well. So are you getting the point here? Yes, you have a question? Yes.
Percent is equal to this 2 billion.
Yes, exactly. So 44%, right here, if you see.
44%, but the penetration is 44 point.
Yeah,
right?
penetration is 44%. That means only if you consider the whole population in Asia,
Asia.
almost like only half the people have connectivity. Right? But that half is equivalent to 2 billion people. Right? So that means another 2 billion people are still there to grow. Right? We still have to fill that 2 billion more people. Yes, I mean, because they don't have connectivity still. Yeah, so because if you can see, if you see the world,
Either they are not connected or they don't have, that means either those people are not connected or they are not.
Yeah. Users.
Individual
Yes,
users.
yes.
Actually, it's a rough estimate.
Yeah.
That's coming up.
Which is tied to technical infrastructure. In other words, on the previous slide, what we would learn is that people don't have access, or they don't have the means to get on the internet, or it just doesn't exist where they live. Something in that
Can be the both. Right now, some of the areas, now the China is in the city-wise, if you take it, they are highly, basically urbanized areas, they are connected. But there are some areas they don't have they may have, but they may have internet, but they are not connected also. We don't know that.
There could be several reasons. One is the device. You don't have a smartphone. Most of the world countries are connected to internet via mobile device, and the device matters for third world countries because you cannot afford a smartphone. That is one point, and the other one is they may be not aware of what purpose the internet serves you for.
Yes.
So there is still community like that. They don't want internet. They don't have any use of internet.
But
you're right.
But actually, there is now. If you look at it, population-wise, if you look at now, China has about 1.1 billion, right? I think the Chinese connectivity. I think something about what now. You have any numbers on that?
You mean
The number of users in China right now?
I can't, out of my mind, I can't say that.
It's about 3. I can't. But if you take India, India has also 1 billion people. But I think it's about 325 million only connected to internet in India, if I remember. So you can see those are numbers.
That is why those numbers are quite low, right? Even though we have, see, one thing is, of course, in Asia has got 2/3 of world population, right? If you consider the Asian population versus the world population, Asia has got 2/3, because China and India itself is like 1/3 of world population, right? So if you combine the whole of Asia, it's like 2/3 of world population. So that is why, actually, bottom line, what we have to get here is that in Asia, we have to grow much bigger.
Much bigger.
Yes.
But if you take Philippines also is very highly, I think they are one of the highest number of mobile phones is actually Philippines. Then you have Indonesia is another large population. Then comes to Pakistan and Bangladesh together will come to about 300 million. Bangladesh has about something like 80 million, I think, 80, right? Then so it's a huge our population is massive, but the more than 50% of the people have no access to internet, or they are not connected.
The question that follows from your
need to say we have to get those people
That's
online.
right.
Yes.
Then the question becomes, why aren't they online? Is
Yeah.
it technical infrastructure?
It's
Is
both.
there some issue? Is it they don't care or they're not interested? So
all
then
of
that's the
those.
next question.
All those reasons.
Is
All of
what
those
are the
issues.
motives
Yeah.
or the technological issues involved? And how
It's
can
not-
those
it's not-
be addressed?
It's not just one reason.
It's not just only one
multiple
reason.
reasons.
Yeah.
I get
Yes.
that.
But most of the time, I think the advancement of let's say the connectivity in the future will be with the mobile,
Yes.
as Asela pointed out. So now that's what we are seeing right now. So as we go on now, like in Sri Lanka, if I give a simple good example, now we have 20 million people in this country, right? We have 21 million phones, right? I don't know whether you know this. I think I'll give you the statistics. 2014, we basically passed the 21 million in 2014 mobile phones, out of which, now this is really interesting, right? Out of which almost 40 some percentage is our smartphones. You can see that's almost 50%. The 50% of the phones that we use in Sri Lanka are smartphones. That means 50% of the people have very advanced HSPA type of connectivity in Sri Lanka right now, right? So there's a very interesting statistics. I'll tell you another. But then when you take the number of people who are on the internet, we think it's about, when you take the real statistics, people say it's about now the what we got recent estimates, about 30%. 30%. That is so the rest of them are not connected. If you look at it. What I'm trying to say, the point I'm trying to make here is a statistical analysis. When I saw the Department of Statistics, they were coming and say internet connected about 30%. That may be right because we have something like 2 to 3 million Facebook accounts from Sri Lanka. So that's about roughly 30% of the Sri Lankan population.
Okay.
Right? But it may be 50%. The people, somebody may have gone. I mean, if you ask email or whatever, it will be about 50%. We don't know. We have not get the hard statistics right now. But you see the disparity here.
Yeah.
But let me also tell you about the connectivity. I'll just give we are much better than majority of the countries. If you take 3.5G, we are about, that is HSPA. I think Asela is not here, right? Is Asela there? Ask him to come because this is very interesting. I want to give you some statistics with what I know, but I don't know the latest ones, right? I'm giving you about year and a because I was a TRC consultant in 2014, so I know the statistics at that particular time. Asela can give you better statistics. HSPA, I think, covered about 85% of the country, right? HSPA is about 85% right now, right? HSPA, yeah.
It is covering around
85. That's what I was told. And but they had the idea of by the end of last year to be 100%, right? But if you take 2G coverage, it's almost 100%. That's what they're saying.
Now we are in LT, right?
Yeah, that's right. More than that.
Yes.
So
that is LT is covering the major, because LT coverage is very peculiar because it has very small cells.
Right.
So the coverage doesn't span a big area.
It's
so
about what
it is. I think all operators taken with, because all operators are overlapping each other on the dense.
So anyway, what I'm trying to tell you is Sri Lanka
maybe
is
like
some or
30%.
the other connected, right?
Yeah.
We are much better than a lot of other countries.
Yeah.
But the problem is now I'm also do a lot of application development for the now when I did for this agriculture recently, we did this drought relief and
we can take a vote from here. Anybody doesn't have your mobile data coverage here?
Now, everybody has
at your home. So
do you have
100% covered? Yes.
I think it is 100%.
Yeah, it's 100%
Right.
within the room.
Then
so
that is not the real issue. Is not that.
the rural.
Real issue is when I did recently with the fertilizer subsidy through all the payments are made to the bank, to your bank. So anybody who had asked for fertilizer subsidy, all the farmers got their subsidy into their bank accounts. When I tried to do that, I realized because we need to get the data uploaded from the periphery in the country. Though we have the connectivity is not very good. The quality of service is the issue that we have.
For banks?
Not for the bank. I'm talking about the data. Some of the areas we don't get, although there is let's say we have 3.5, you won't get 3. When you upload speeds are not very good. Sometimes the connectivity is not good. So we had issues of getting the data. So at the moment we are connected throughout the country. But the quality of service is the one which we have issues.
There are pockets which doesn't.
Not only pockets, there are a lot of areas. I had a lot of problems. A lot of farmers had issues.
Yeah.
So we have a database of 1 million farmers in this country right now, and so that's what these are recent statistics.
That is what I told now. Mobile coverage is very they are very strategically positioned in their towers where the population is. Yes. They don't cover the fields.
So this is the same issue that had gone to China. Same issue had gone to India. That's why I just want to tell you.
Because this high speed is on high frequencies. They don't travel very far.
Precisely.
And they have to have line of sight. So these are the issues.
I think now, Mahi, so you've got a new topic for next IGF, right? So you can, this is a good topic to...
last time, our one topic was regarding the next billionth user. So last time we have discussed almost all. Harsha was presented there. I believe still we have to go in the same topic.
But I think that the Sri Lanka is a good place to actually, because we are an island, it's a very good place to do a good study on this, because we have unusually we have a good coverage. It's not like we have the latest technology. Is that right, Rasaila? We get the latest technology, and this is like a test bed for a lot of technology. We are first in the region. So, but unfortunately, these is some of the issues that we have now. We are bringing is a very good thing to discuss.
Yeah.
And then we were trying to go for the Google balloon. Then we tried all sorts of things. The connectivity issues, right? Wi-Fi, and I have worked with Wi-Fi for some time. I did a Wi-Fi testing for different parts of the country, and we have checked on the Wi-Fi for just giving what you call the telecenters and how it works. So we have found a lot of issues in this country. So it's a good test bed for people to try it out.
Okay, so I think one of the other important thing why I actually put this stats to say that, because we were talking about the IPv4 and IPv6 stuff, right? So because we still have to grow like 2 billion users, because we are still, our penetration is something like in Asia, if you take overall 40 something %. So we still have to double it up, but we don't have enough IPv4 addresses, right? Now, if you consider, I told you like the IANA pool or the PTI pool, it is 0 now. There's no IPv4 addresses there.
There's another issue going to be I will now bring you some of the things that we are doing. There's another issue that we are going to run out of these IP very soon. That issue is the IoTs. There are now I'm testing some devices in the country. There are small devices that you need IP addresses for each one of those. You need an IP address, right? Now, what right now these operators, what they do is they issue a private IPs in the private range, right? So I think you didn't talk about
I didn't go because of the time. So
not only that, because we have run out of the IP. We have used the ports also.
So anyway, the thing is that we don't have enough IPv4 addresses. In fact, actually, if any organization now want to get some IPv4 blocks, say from the regional internet registry, they have a limitation. The maximum you can get is something like /20 1022, which is equivalent to something like 1024 IP addresses. So think about a mobile operator, right? So 1024 IP addresses is nothing for a mobile operator. So so that is why they really have to think about IPv6. So IPv4 we don't see a future. I mean, even after now 10 years, 15 years time, IPv4 networks still will be there, but in sort of pockets. But we really have to think about IPv6. So what I want to actually stress is that don't just neglect IPv6, because IPv6 is very important. Try to learn about it. Try to spend some time working on IPv6 and so on, because that's where the future is, right? So anyway, I think I'll just quickly run through due to the time factor. Yes. Oh, is it okay? Up to 11. Okay.
No, I think this is a good area. I think I think this is a technical also, and I think you should spend a little bit more time on that.
Yes, that's why I said maybe
if you're okay with that.
Yeah, sure. I'm fine. Okay, so I think we talked about routing system. Actually, in routing system, one of the challenges, especially if we are to now work with IPv6, one of the challenges is the size of the routing table. So earlier I mentioned you that if you get if any organization gets an say IPv4 or IPv6 address block, they have to announce it to the outside world, right? Then only outside world can send traffic to their network. Okay, so what you would do is you will make announcement in a table called routing table, and we have global routing tables, we have local routing tables. So you make an announcement. So every time, say, some organization gets some IP address block, announcement will go into the routing table. So over a period of time, what will happen to the routing table? Routing table will increase, right? So say, for example, if you see the IPv4 global routing table now, there are more than 600,000 announcements. More than 600,000 announcements. So that means, that many routing table announcements or prefix announcements are there in IPv4 routing table. So remember I said earlier, the routers, they take sorting, right? They take some decision-making process. They do sorting. And if the router has to scan through 600,000 prefixes, it's not very good. The performance will go down because router has to go through, this is what we call the convergence time in routing, right? So the convergence time become much bigger. So if the convergence time becomes bigger, router performance, the routing system performance is not going to be very good, right? If you want to get from one place to another place, it'll take long time, right? It won't be very quick. So this is why lots of ISPs, lots of operators who would actually announce these prefixes, they tend to apply some filters because they don't want to deal with about 600,000 prefixes. Say they would actually cut it short. Maybe some long prefixes would be filtered out. So they will only have to deal with, say, lesser amount of prefixes. So this is also one problem. If you are going to announce some smaller prefixes into the routing table, there is some possibility that they might get filtered out. But when you come to IPv6, right? When you come to IPv6, we have 128 bits. So that means the tree, because it's a tree hierarchy, right? Even if you take the IP addressing, it's a tree hierarchy. So you have 128 levels. So the tree span is very, very big and deep in IPv6. So if some network, some organization is announcing a small IPv6 prefix, these numbers going to hit not billions, not trillions, even much more, right? So even with IPv6, we have hard time to handle 600,000 prefixes. But when it comes to IPv6, there's no way that we can handle even billions or trillions of routing table entries now at the moment based on the technology what we have now. So this is why actually IPv6 routing is one of the important area for us to consider. If someone is doing some work, some research projects and so on, that's an area that you can look into as well, right? You want to add something there? Or?
Well, that's a compromise that we had made, number versus the routing the table. Well, there were some, I remember there were certain arguments about this going on.
Yeah.
One of the things that would happen, actually, the routers become much more, it would be much faster.
Yeah.
That means a hardware level, so that you would be able to handle this. That's one of the things that they were talking about at that time. But we need to have some more better algorithms, routing algorithms, to deal with that. So that's a good area to do some research, actually.
Yeah. Okay, so that's some discussion on the routing side. Then also we have, okay, now we talked about IP addresses, and I ask, is it easy for us to remember IP addresses? Not very easy, right? So what's the best way then? If you can't remember IP addresses, IPv6, anyway, it's very, very difficult, right? So because they are all hexadecimal numbers. So easiest way is you map that to a name, right? You map the IP address to a name, just like what you do in the phone book, right? Your address book. So you have your friend's name against the friend's phone number. So you don't really keep your friend's phone number in your memory. You can just dial, pick the name. So same thing. So we have what we call DNS, or the domain name system, that maps these IP addresses to a name. Simple as that. Because humans, we can't remember these IP addresses. So nowadays what we do is we just type the domain name. We type www.google.com or www.slt.lk or whatever, right? So you type all that. In fact, nowadays even you don't type it. You just open the app, right? So when it opens the app, behind the scene, what happens? It's really a DNS query. It's a DNS query what happens when you open an app. So that is why also nowadays there are lots of security risks and threats, because you don't even know what you're doing. You just open the app, and if it's infected, it could be taking you to some unknown places and so on, right? So that's a whole security issue behind that. But let's try to spend a little bit of time on the DNS. Now, DNS is a database, actually, right? So if you consider domain name system, it's a database properly structured. It's properly structured. It's like a tree hierarchy. In this tree hierarchy, top of the tree, we have what we call root, right? Root. So root sits on the top. And then next level is what we call TLDs. You can see in the left side, it's written TLDs. So TLD stands for top level domains. Top level domains. Now there are different types of top level domains. There are things called GTLDs, or generic top level domains. There are things called CCTLDs, or country code top level domains. There are things called IDNs, internationalized domain names. So these are all sitting in that top level hierarchy, or the one below the root, or the top level domains, right? When DNS was designed quite a long time ago, there were only seven TLDs. There was .com, there was .net, there was .edu, like that. There were 7 of those, and also these were only like 3 characters. That's why you see only .com has only 3 characters, edu has 3 characters, gov has only 3 characters. That was kind of a restriction. And but nowadays it's not like that. Now this has grown quite a lot. So if you count the number of TLD domains at the moment, there are over 1,500, right? It's not just a few, because we have, as I said, like GTLDs. Also, we have something called new GTLDs. What are new GTLDs? Has anyone heard about it? New GTLDs? New GTLD stands for new generic top level domains, right? New generic top level domains. See, generic top level domains are like .com, .edu. The .com was meant to be for commercial entities, .com, right? And .edu was meant to be for educational institutes. .net was meant to be for network operators. So it had a purpose. But now we have new generic top level domains. So this means, so this application round started in 2012. I mean, these are all based on community input. So community discussed that this is some need. So so application process was handled by ICANN, And so initially in the first round, I can receive almost close to something like 2,000 applications, 1,900 something applications was received in the first application round. So still that application round is being, the applications are being evaluated. So it's not finished yet. So far, around 1,500 that's correct, right? Around 1,500 has been delegated as new altogether in the top level domain. So if you consider the new GTLDs, some examples like, say, there are cities like .Tokyo, there are professions like .engineer or .lawyer, right? And then there are various, corporates. They have got their own domains like, Google and Yahoo and so on. And then lots of other, other generic names. There are, plenty of those, around more than 1,000 or so. So these are what we call new generic top level domains. And so after the first round of this application, once that is over, there may be another second round as well. So these things will evolve, right? Now, CCTLDs are, yes.
So if you recall, I mentioned a little bit about the generic top-level domain name yesterday, right? So these are the new top-level domain names like .. Champika gave you a different set from what I mentioned, but these are in total, the what is on offer improves the competition, the consumer choice. So I mentioned about .guru, I mentioned about .shop, .coffee. These are different things.
Right.
And Champika also mentioned a subsequent window. Maybe not round, but it's a subsequent procedure to allow even more of such names to come in. So if you recall, I mentioned about the the policy development process from the multi-stakeholder model discussion yesterday. So all these came from that policy development process. The next procedures, the next round or the next window for new names to come in is also following this development process. And a lot of people are discussing, so what is it going to look like the next cycle, the next round, the next procedure for getting new names? What are the policy? What are the new rules? What are things that worked well in the past? What are things that didn't work so well? What are things we want to change? So all these are currently being decided and discussed at ICANN meetings right now. I just wanted to add that just to put you back to what we discussed yesterday on the policy development process. You could see that this is a very good example of a topic that's currently being discussed.
The purpose of the new names would be what?
Okay, so as I mentioned, all this is a result of the community coming up with proposals to say that they need new names. Okay, and so the idea is that it improves consumer choice. You can imagine that with the new slew of new generic top-level domain names coming on board, you now could get Dominic something rather than Dominic.com. I'm sure it's been taken.
Yeah,
I don't know, but I'm sure it's taken. Sorry, Harsha, you have something to add?
I think one of the things is now you take IBM, for instance. I think .IBM is there right now. So the .IBM is the new generic name. So instead of actually IBM.com, so it goes to the second level, right? So they will have their root as .IBM. So some corporates like to have their domain name as the top level. So something .IBM. So the idea yeah. So rather than actually .com makes it diluted. Right. So the idea is that what ICANN gave us, they opened up this 2012, and I think about 1,000 applications. I think about 2,000. You said 2,000, right? So even we were thinking of having .Colombo, for instance. So if you want to have .Colombo, if you decide on .Colombo is a great thing to have, I think $50,000 US. I think we can get it, right?
So improve increased consumer choice. Now you have more choices of names. Innovation industry, you can think of new ways to have how you want to have your name.
So you want to brand it, basically.
Yeah. So a few points.
We had another. I just want to add on to something. There is a .asia came before. About 2000.
Around 2000, they increased. They increased the
there is an increase TLDs called co-op. Now the early only 3 letters.
3 letters. 3
you
characters.
Co-op, ARO, and museum.
Like
These
.travel, .travel, .aero.
That's
yes,
right.
Yes.
So those
.info. Yes. Yeah, I'm going to actually talk about that.
The next one is that.
So I was talking. So far, I was talking about the GTLDs and the new GTLDs. Then the next thing is CCTLDs, country code top level domains. So country code top level domains are like every country in the world. They have got a 2-letter. It's an international standard, the ISO standard, ISO 3166. Based on that, every country has got a 2-letter country code. Say, for example, Sri Lanka has got LK. India has got IN and so on. Singapore has got SG and so on. So these are all 2-character or the ISO standards, right? 2-letter ISO standards. So CCTLDs are those, right? So there are 200 something countries, and so these countries, they have got their own CCTLD. And then the IDNs. IDNs are internationalized domain names. So in fact, actually, I'll go there to that, jump into that slide. So these are all the new GTLDs. Actually, I was going to show this. We talked about it, like things like .menu, .paris, and so on. So these are actually the IDNs, or internationalized domain names. You can see that several countries in the world, they have been delegated these IDN strings. So if you see that in Sri Lanka, right? So you have Sinhala script, and then you have Tamil script. So that is the local language script. So if we want to, have our local language domain names, we should be able to have that, right? But the thing is that now we have to define rules, proper rules. So this is something very important. So this is where we have to define the labels, proper labels, because if you really think about it, DNS resolution, right? In DNS doesn't understand all these local language scripts. The resolution happens based on the ASCII, right? So that is why we have to convert these local language scripts into the ASCII, the ASCII format, basically, right? So we have to have a code for that, proper code for that.
But actually, can I add on to that one? By the way, Sri Lanka is one of the earliest countries to have the .lanka and .ilange. We were the non-Latin. I think we were the either first or second. I think, I'm not sure.
Yeah, sometime back.
Yeah, back. Our .lanka and .ilange actually, but few years back. So now at the moment, you can actually have .lanka in Sinhala script or .ilange in Tamil. Actually, we are giving it free now at the moment. So if you want, you can get your you can ask for it with a dot. Let's say you go for CCTLD .lk, and then if you request, you will get .lanka as well. Right. So we have done our rules now.
And one more important thing, actually, we should touch on here, which actually where we haven't really done much work, which is we talked about the next round, right? The new GTLDs, the next round. So if there is, say, for example, in the next round, if it opens up to IDNs, so that means, people should be able to request for TLDs in their own own labels, own scripts. So that means, say, for example, say your name in Sinhala or your name in Tamil, right? So you should be able to get that as a TLD. So that process should be possible. But the thing is that still we are not there yet, because we have to generate those labels, the rules.
Yeah, at the moment, there is a committee is being. Now we are thinking of appointing a committee.
Yes, so that's something that we have to
already
work.
That we are discussing right now.
Yes.
So But there are few technical issues as well. I will later on touch upon if you permit me to do that.
No, go ahead. Yeah, it's okay.
Well, after that,
Okay.
there are a couple of problems. One of the things is at the moment we have issues of we have a zero. I don't know whether I don't know whether I should cover this here. In Sinhala, there are something hidden characters when we do the rendering. Call a zero with joiner, right? So if you want a yansaya, rakara ansaya, all of those, there is a hidden character, hidden code points are going in there. Those ones we can't put at the moment. We have an issue of putting in there. So at the moment we are discussing about that, how to do that. So if you write Shri, for instance, there can be an issue because there is a for Shri, you have a rakara ansaya. Rakara ansaya has this zero with joiner in there. So anyway, we are discussing this, right? So we will come up with a proper solution.
Yeah.
So don't worry about it at the moment.
Yeah. So I think these are all good discussions, and also in case if there are anyone here, like if there are people here who are interested in this field, if you are especially developers and so on, do express your interest, and then you can these panels can be voluntarily. You can volunteer in these panels and so on. So if you have some deep interest, feel free to join these panels and contribute as well. So this is something that we're just openly telling you. Okay. Yeah. So these are IDNs, and I was also actually going to touch on a little bit on this. So in DNS hierarchy, you see that on top of the DNS hierarchy, we have what we call root, right? Because root is the top of this database. So root would delegate part of its database to .com. And then part of its database to .net and .lk and so on. These are what we call delegations. And then say .lk can delegate part of its responsibility to something .lk, right? So these are what we call delegations. So if you really see the root database only has got entries for the top level domains. So if you really consider root database as say a file, here you will have all those .coms, .nets, .edus, .lks and so on with pointers to their appropriate name servers, because that database has to run in a name server. So that's how the DNS queries get resolved, right? Now I won't go into too much details because then it'll get a bit technical, but try to understand the conceptual thing here. So if you are talking about the root database, so say you are doing some DNS query, you open your app, right? Or you type www.google.lk. If you type www.google.lk in your browser, how does this query gets resolved? Because you are the client, right? So you have your device, you have your browser. So this is a query. It's a simple DNS query. So basically, if you want to visit www.google.lk, what you need is the IP address. Remember in the beginning, we talked about TCP/IP. In TCP/IP, IP address is in the layer, the network layer. So that's where the communication happens. So if you have to go and talk or communicate to the google.lk web server, you have to know the IP address of that google.lk web server. You have to know the IP address. So you are asking DNS to give you that IP address. So you will go and talk to your local DNS server, right? So this local DNS server could be, say, if you are connected to a network here, the network could be giving you that local DNS server. If you're at home, your ISP is giving that network, DNS server, and so on. Or sometimes you could be using Google DNS server, like 8.8.8.8.8. So these are all what we call recursive DNS servers. Will give you the answer of that name that you are requesting for, right? So these DNS servers, when you go and tell your DNS server, give me the IP address of www.google.lk, those DNS servers will go and talk to root, because root has got the database about .lk. Because if we have to go and talk to www.google.lk, we have to find, we have to go through this hierarchy. So first the query would go to root, and then root will say go and talk to .lk servers, and .lk servers will say go and talk to google.lk servers, and then google.lk servers will give the exact answer about the IP address of www.google.lk. That's how the DNS queries get resolved. It happens very quickly, right? When you type, you get the Google web page, it happens very quickly within few milliseconds, but that's how it happens. Now, if the root, now we talked about root database. So we have to keep this root database in servers called root servers, right? So root servers are quite important in this operation, because if we don't have root servers, there's no one to give us where is .lk or where is .com, where is .net. So that is why we have to have these root servers, and they are a critical part of internet. If there is no root, the whole thing will collapse, right? So that is why we have to make sure the root servers are well protected. Even if there are some attacks coming into root servers, they are properly managed. Nowadays there are attacks, things like DDoS type of attacks. So if there are these kind of attacks are coming through to these servers, they have to be properly handled. So we have to plan the capacity and so on. So it's a big operation, right? So those servers are called root servers. So whenever, when you do some new DNS query, it is very much likely that your recursive server, first time, it will go and talk to these root servers, unless it has got the answer in its own memory or own cache, right? So now the next question is, where are these root servers? So these root servers are located everywhere in the world. So there are over 600 root servers. There are over 600 physical root servers located in different parts of the world. Actually, if you zoom in, we some time back we put a root server in SLT network as well, but it's not live now, right? So it is not there. But we are also working with some of the other operators now to put some root servers in Sri Lanka here, right? But here, in case if there are some more operators who are willing to have some root servers in your own network, we can discuss with you and see what sort of requirements that we need to go through, and we are quite happy to work with you and see whether we could have a root server in your network as well. Because having a root server in your network, say for example in Sri Lanka, if you have a root server in your network, the response time will be much faster, much better, because you don't have to go to outside world root server to get it sorted out. You can resolve that within your local environment as well, right? So that's something that just want to, yeah.
I thought we had a one, right?
Yeah,
there was a mirror.
Yeah, so there was one before, but it's not operational at the moment. So they are working on it to get that.
When did that happen?
Recently. Yeah.
Wow.
Yeah. Okay. Okay. Now, so we talked about DNS. Now, attacks. These are very common, right? Everyone talks about attacks. Everyone talks about security, right? One of the very common problem is what we call man-in-the-middle attacks. So what are these man-in-the-middle attacks? Something happens between you and your destination, right? So say, for example, this can come in various forms. Your DNS queries can be hijacked. You could be taken into some malware infected sites. And so it can happen in various ways. I can give you some examples. Say one common problem in DNS, especially focusing DNS, is what we call cache poisoning. Have you heard about it before? Cache poisoning. So say I am a recursive server, right? Say I'm a recursive server. Say I'm ISP. Think that I'm ISP. So you are my customers. You are my clients. So my recursive server, my DNS server is giving you a service. So if you want to visit any website, if you want to send some email, you will talk to me to find out the IP address, the name resolution, right? You will talk to me because that's how it's configured. You will go to your ISP DNS server, right? So when you ask me that question, give me the IP address of, say, your bank, right? I will go and talk to root servers. Then root servers will go and tell me, go and talk to the next level servers and so on through that DNS hierarchy. And then once I find the answer, I will return you that answer. So once you got the answer, you can go and visit your bank website. But now that answer will be in my memory. I will keep that in my memory because next time if you come again asking for the same question, I don't have to go through that root and other DNS servers. I can straight away respond from my memory itself, from my cache. That's why we call those as caching servers or recursive servers. Now, if I keep that answer in my memory, in my cache, what happens if someone poison that cache or say corrupt that memory? Okay, so say you're asking me, give me www.mybank.com, right? So I found it, I went to root, I went to .com, I went to mybank.com, and I found the IP address of their web server. And now I'm keeping that IP address in my memory. So say some attacker managed to corrupt my memory and change that IP address to a different IP address managed by the attacker, right? So that IP address could be a server. It might belong to a server managed by the attacker, maybe in a garage or somewhere, right? So then what happens? When someone asks for www.mybank.com, I will respond with the wrong IP address, right? I will, because my memory is corrupted now. So I will respond with the wrong address, and then you will then go and try to connect to a wrong web server. But that website might look the same as your bank website, but it's not really the bank website. It could be a bank, it could be your Facebook account, it's social media, whatever, right? So you might try to log in, you might try to give your credentials, your user ID, passwords, and things like that. So these things can be stored easily by the attacker into a database, and then they can be even sold or used for some malicious purposes and so on. So these are what we call pretty much cache poisoning attacks. Cache poisoning attacks can happen in various ways. I only gave you one example, but it can happen in various ways. Another example could be DNS through DNS hijacking. In DNS hijacking, nowadays when we go to say in public places, we connect to free Wi-Fi hotspots, right? When we see some free Wi-Fi hotspot, we would connect. Okay, I can straight away use this in hotels, in airports, and so on, right? So, but how can you trust it? No, you can't trust it, right? Because you are using someone else's infrastructure for you to actually go and connect to the web servers and things like that. So they are providing you the infrastructure. So they can easily take you to wrong places and so on. So these are, again, other ways of how they can hijack our DNS queries. Some more ways through malware. So what are the malware? Someone can operate a nice website with a lot of nice contents, and then these websites could be malware infected. So malicious softwares, basically, right? So if you visit those websites, the malware can download into your device, your mobile phone, your laptop, and so on. And then malware can change quite a lot of things in your device. Maybe it could be changing your DNS server settings. It could be changing something else. If it changes your DNS server settings, what happens? Then you might think that you're doing proper queries. You're going to your real bank website or real facebook.com, but they could be taking you to somewhere else because they control it now, because it's malware infected, right? So these are very common threats that we see today, where people would, through various things, they would infect their systems and so on, and these compromises can happen, right? So these are what we call man-in-the-middle attacks. Now, how can we protect these? There are various ways how we can protect these. There are security mechanisms. I just want to quickly touch on something called DNSSEC, actually. So DNSSEC stands for DNS Security Extensions, right? DNS Security Extension. So this is a way, I won't go into too much detail, but what we are doing in DNSSEC is your DNS database, whoever, say if you are mybank.com, when you run if you are the mybank.com, say you are the administrator, your database records can be signed digitally, right? So you will have a signature associated to all those data records you have in your DNS database, right? So that means if the recursive servers can verify these digital signatures, whether it's really the correct signature, then they can validate those responses and send you to the right places. If they validate, if they say you want to visit mybank.com, www.mybank.com. So recursive server will send you there only if the recursive server can validate those signatures. If not, it will drop, right? So these are ways where we can actually implement these kind of security mechanisms and then try to protect these sort of situations. Now, in DNSSEC, if you see the root in DNS system, the root zone has been signed, right? Root zone has been signed. So you have, the signatures and so on. And then the next level, TLD levels, if you consider the whole world, almost like 90% of the TLDs, they have signed their TLDs. If you consider .coms or .nets and so on, the 90% of TLDs have signed. If you consider country code top level domains like CCTLDs, larger percentage of CCTLDs also signed. One good news in Sri Lanka is that .lk has signed. In fact, actually, again, one of the earlier...
I signed.
Yes. Okay. Yeah. So, in fact, a few years ago, actually, I think around 2010, I believe, yes,
2010.
.lk was signed. So why not get the advantage, right? So if you run your own website, say your corporate website, say your company, when you go back to your companies or when you go back to universities and so on, think about, deploying DNSSEC, signing your zone, because then you can establish trust with .lk, right? .lk servers. So always when the DNS queries get resolved, these validations can happen, and then whoever the clients who are visiting those websites can be sent to the right places, right? So these are some things that we can do from our side. So from a security point of view, a few things to consider when you want to really deploy some secure system. Confidentiality is one important thing, right? So how many of you send confidential emails, right? Yeah, so you send confidential emails, but what do you do to make it confidential, right? Okay, yes, very good. He does encryption. Who else does encryption here when you send emails? No one? Anyone does encryption when you send emails? Yeah, so we have someone. Yes, very good. If you don't encrypt, it can be traced. I mean, there's no confidentiality factor. We're achieving that, right? It's just like when you send an email, it is similar to sending, I would say, a postcard in a postal communication, right? When you put a postcard, postman can see that, right? It's not like a letter, right? It's a postcard. It can be seen. So if you send a plain text email, the same thing, right? If you want to send something confidentially, you have to encrypt it, right? You should encrypt it. And then authenticity, right? Authentication, that's another important thing. If you send an email, how do you know whether, or say the receiver, say I'm getting an email from you. How do I really know whether you're the one really sent it? It could be coming from someone else, right? But pretending to be like you. So how do we ensure that? So what do we have to do there? We have to sign our email. So if you're going to send some email, what you could do is you can sign your email. So when you sign your email, that means receiver knows, right? Receiver can verify your signature, and receiver knows that it's really coming from yourself if the receiver can validate the signature. So make sure that these are good practices: encryption, signing, and so on. Integrity. What is integrity? Integrity means the contents are not being altered, right? Changed, modified. So that's the integrity. It should be intact. If I send you a parcel, you should get that parcel in the same way. It should not be tampered, right? So that is what we call integrity. We try to achieve integrity there. Availability factor. What is availability? Availability means, so if you are running some servers, in case if something happened to that server, you should make sure that service is still available. If you're running a web server, in case if someone DDoS your web server, attack your web server, if your web server goes down, then all your web service is going down, that's not very good, right? You have to make sure that you have availability, right? You have a service. Same thing, whether it's web server, DNS server, mail server, and so on. So you have to have some multiples of those. In case if something goes down, at least you have some others to serve your clients, your customers. Availability factor. So these are all important things when we think about having a secure network, or in general, secure internet, right? So I think, just the last slide, just I want to actually quickly point it out, as Harsha said, preparing for future, IoT. So in the future, we have these Internet of Things, right? Internet of Things. So which means anything around us can be connected to the internet. It's already happening, right? So there are lots of home appliances, refrigerators, microwaves, fans, light bulbs, whatever you name it, right? So all these things are connected to the internet nowadays, right? So in the future, it'll be more and more, or everything around us will be connected. In the same way, obviously, the challenges would be then the security factor, right? If you have to talk about the IoT, security will take a big important discussion over there. So that's something to work on. And then proper protocols. If you're talking about these devices, they are very small devices. It could be very, very small devices where we can't give too much power, low power devices. So if you're talking about low power devices, you can't really have big headers like IP headers, IPv6 headers, V4 headers, and so on. So we have to have some header compression so that they can handle these, right, with low power. So we have to work on some. I mean, it could be based on IPv6. In fact, there are some new protocols that they have developed based on IPv6 as well. So there are plenty of opportunities around these areas in IoT that you can, especially if you are some researcher, if you have some interest into the future where you want to do some further research, IoT is one good area that you can select as well, right? You want to add something there, Harsha?
Actually, IoTs, I think now it's starting in Sri Lanka. So we can have a discussion subsequently, I think, when we get together, all of us.
Sorry? Oh, yeah.
It's defined in the sense it's an Internet of Things. It stands for Internet of Things. It's basically actually the devices talking to devices. So in the sense, like, I'll give a simple example. Let's say a good example is that I can, from remotely, I can turn off these lights. Or when you let's say that you need to heat up your apartment, for instance. So you don't have to do it, inside the apartment, but you can do it from outside. You can have the heaters turn on outside. So these devices are actually talking to servers. Then you can talk to the servers, and you can do these things, light up and heat up or whatever.
Yeah, we do that. Even I switch off my light bulbs at home using my mobile phone, mobile app. Right. Yes.
So the other thing is, now there are a lot of these devices are going to be there. Like, for instance, now we are actually experimenting with the sensors, like fertilizer sensors.
Yeah.
Then we can have let's say you can find out the water content in the soil, moisture. That kind of stuff is very important for a country like ours, which is very agriculture based. So we are basically testing a small devices. Like there are boards now, small boards, the circuit boards called Arduinos and the Raspberry Pis. It's a very small computers where you can connect devices, and then you can put a SIM there, and then the SIM we can talk to the server. So we can send the data streams to the servers where we can collect data and we can analyze this data. So that's what we call a big data. So that's also happening right now. So in Sri Lanka also we have several companies right now working on this.
Yeah. Especially, I mean, in pretty much in every field, manufacturing, medical, especially medical field. Yes, there are plenty of applications, even quite a lot. Even if you consider your car itself, so many devices inside your car can have a lot of car manufacturers. They're having pressure indicators. Even the manufacturer can check when you travel, your car pressure, tire pressure can be checked using those devices and so on. So there are plenty of applications. Yeah. So that's another big area, right? So proper protocols, working on those security factor and everything, right? So I think probably, given the time factor, I think probably we'll stop at this stage. Maybe we'll give some little bit of opportunity for if anyone has any questions. Anyone has got any question?
I have a question about the DNS servers. And if I develop a website, unfortunately, I want to transfer my website to another hosting. Domain is same, but IP is going to be changed. Now, I changed that website to a new IP address. Now I check that website. My DNS server doesn't take effect. It's showing the older site from the older server. Now, Mr. Kelvin, example, visiting that website from Japan. He's seeing that website, a new website from the new server. Now I go to the back end and update the site. Its new content is not showing on his computer because that is not updated on the new server. So we can solve that problem using DNS servers like the LKDNS or Cloudflare DNS, something like that. But what can we do to solve that problem if we use our own DNS servers?
Okay. All right. So one important thing in DNS, just to understand, is DNS data doesn't propagate instantly, right? So if you say, for example, if you're running your DNS server, if you do some change to the database, that means, say, somewhere else in the world, some recursive servers or caching servers, they could be keeping your old IP address in their caches. So if the client is talking to that recursive server, say, for example, say Kelvin is a recursive server which is in Singapore, and I am here in Sri Lanka, right? So I have changed now my IP address. I can say my first ISP is not giving me a good service, so I went to a second ISP, so he gave me IP address. So now my web server is running on a different IP address. So, but Kelvin still has my old IP address in his memory, in his cache. So if some client, someone in Singapore who want to actually visit my website, they will be asking Kelvin, what is the IP address of myself? Because Kelvin has got that old answer in his memory, he will respond with that wrong IP address. So obviously the client then cannot visit my website. So that is why. So if you are doing some change, what you need to consider is, first of all, allow proper time to propagate that DNS data into the caches, right? So that's one important thing. And the other thing is, if you have done some change, you have to make sure you inform your parent. If you're managing your own DNS, say myweb.com, say, for example, right? So if you're running the DNS, say your name server could be ns.myweb.com, right? And if you have changed the IP address, your parent would be .com, right? So .com should be informed, because remember, when the DNS query gets resolved, query first go to root. Root will say, go and talk to .com. And .com is the one who will say, go and talk to myweb.com. So if you do not inform your parent, whoever the parent, if it could be .lk, it could be .com, whoever it is, if you do not inform your parent, it's not going to resolve. So these sort of things, what we call as lame delegations. So you should not have any lame delegations. So these are some good practices to consider if that is happening, and then we can avoid those situations.
And it all depends upon how long that you keep the records also, right? In the DNS.
Yes, the TTLs, the time to leave.
Timed, yeah.
Yes.
Normally SLT is fairly long. It's roughly about early. I don't know now. Roughly about sometimes it will be there for about 2 weeks. Even if you change it, normally it's a 72 hours. If you change something in the root DNS service in the LK domain root service, you will within about 72 hours it will get flushed and it gets propagated. So normally, whenever you tell the client, let's say you are handling a client, tell the clients to wait 72 hours for the proper delegation. Right?
You can check that. I mean, if you are the administrator, you can have a look at your zone file and see what are the TTLs. Yeah. Any other questions? Okay, I think Mahi is looking at me, so probably the tea break. So let's beg for tea, and it's a good discussion. So feel free to, we'll be around today, tomorrow. Feel free to talk to us, any of us, if you have some more questions and so on, and we can be in touch as well. Okay, thank you.
Thank you, Champika and Harsha sir. And there is a query form outside where that you have to fill on. There is a gift going to give when you fill it. Please be free. There is the form in the registration desk where that you have to fill online. While you're having the tea, please fill that form and please be present 11:30 into the session room. Thank you very much.